Problem number 21, evaluate the integral of arctangent of x. So whenever you see an integral that involves an inverse trig function, like this one right here, you should think integration by parts, and you should probably set your u to be the inverse trig function. Well, if this right here is your u, well, dv is just going to be dx. Okay, let's see what this gives us. du is going to equal, when we take the derivative of arctangent, we should know that's 1 over 1 plus x squared dx. When we integrate dx, we just get v is equal to x. So it might look like we're going in the wrong order here. dv is dx, we've gone from 1 dx to x here, but we're going to be able to do an integral by substitution. Let's see how that works. So we would end up with this is equal to uv minus the integral of v du. U is arctangent, v is x, so x arctangent of x minus the integral of x, that's v, times du, 1 over 1 plus x squared. So this integral right in here, x times 1 over 1 plus x squared, this is something that can easily be done by substitution. U is 1 plus x squared, du is 2x dx. So x dx is equal to du over 2. So there's du over 2. And so we end up with x arctangent of x minus the integral of du over 2, and then there's also a u downstairs. And so what do we end up with? 1/2 the integral of u is natural log of absolute value of u plus c. And our final step is we have to substitute in back in. Don't forget that final step in these kinds of problems. X arctangent x minus 1/2 natural log of 1 plus x squared. I'll point out here that I dropped the absolute value bars because 1 plus x squared is never negative. Okay, so that's this problem. Big thing to take away from here, whenever you see an arctangent or arcsine or arccosine or something like that, an inverse trig function and an integral, you should strongly consider integration by parts.